Good morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about image segmentation. So what is image segmentation? Image segmentation is one of the image analysis methods used to subdivide an image into its regions or objects depending on the type of shapes and objects searched for in the image. Image segmentation is an essential first step in most automatic pictorial pattern recognition and scene analysis tasks. So what are the applications of image segmentation? So inspecting images of electronic boards for missing components or broken connections, detecting faces, facial features and other objects for surveillance, detecting certain cellular objects in biomedical images. So image segmentation is one of image analysis method used to subdivide an image into regions. Suppose if I am taking one image, in that image there are certain objects are there. Suppose one object is a one person, another object is there. Sir, what is that? It is a box or anything. So it is one frame. So anything. So in the background. So how many segments are there in this frame? There are 3 segments are there. How we are finding out? So in the frame, how many segments are there? Segments mean how many objects are there in the frame or in the image. That is the segmentation. So how we are finding out? It is the analysis and it is a process to finding out the what is the shape, original shape and the size of that image. We have to find out. So it is the image analysis method used to subdivide an image into its regions or objects depending on the type of shapes and objects searched for in the image. So image segmentation is an essential first step in most automatic pictorial pattern recognition and scene analysis task. So there are different applications are there for using the image segmentation. So inspecting the images of electronic boards for missing components or broken connections. Suppose I am taking one electronic component. Okay, there are different ICs are there. Some ICs are there or some many small devices are there. So how many are there? First we have to take that one. After that, using the image segmentation, if any of the object is missing, it will be shown like this. So how many are there in the frame? On the original, how many are there? After that, how many are there? So image segmentation is finding out what are the objects are there in the electronic board and broken connections. So detecting faces, facial features and other objects for surveillance, detecting certain cellular objects in biomedical. So detecting faces. Suppose one image is there. Here another person is there. So how many persons are there? How many objects are there? So here 2 persons are there. How it is possible means we are capturing the faces. So detecting faces and facial features and other objects for surveillance. Suppose there are different. Suppose here 3 persons are there and one frame and one any of the some boxes are there or any luggage is there. So how many objects are there? It means total segments are 6. But how many faces, how many persons are there? Means it will be finding out the faces. So detecting faces, facial features and other objects for surveillance. So detecting certain cellular objects in biomedical images. So segmentation approaches. Image segmentation algorithms are based on one of 2 basic properties of gray level values: discontinuity and similarity. So similarity means similar, both are similar. Discontinuity means both are different. So in the first category, the approach is to partition an image based on abrupt discontinuity, that is change in gray level such as edges in an image. And the second category, the approaches are based on partitioning an image into regions that are similar according to a set of predefined criteria. So any of the image segmentation algorithms. So image segmentation is an algorithm. It is an analysis to finding out the segments in the image. So it is algorithms based on 2 basics. What are that means? Discontinuity and similarity. But these are depend on your gray level. Every segmentation is in the gray level only. We have to find out easily. Gray levels are in segmentation. So discontinuity and similarity. So the first category, the approach is to partitioning an image based on abrupt discontinuity, that is change in gray level such as edges in an image. And the second category, the approaches are based on partitioning an image into regions that are similar according to a set of predefined criteria. So we shall focus on segmentation algorithms to detect discontinuities such as points, lines, and edges. Segmentation methods studied here rely on two steps: choosing appropriate filters that help highlighting the required features and thresholding. So, suppose if I'm taking one image that is x-axis and y-axis. So, in that x-axis and y-axis, we shall focus on segmentation algorithm to detect discontinuity such as points, lines, and edges. So, in that, how many points are there? How many lines are there? How many edges are there in that one? So, we have to find out how many points or objects are there. So, we shall focus on segmentation algorithm. So, any algorithm for analysis. So any of the image processing algorithm, it is using for the analysis purpose. So these segmentation algorithms to detect discontinuities such as points, lines, and edges. So segmentation methods studied here rely on two steps: choosing an appropriate filter that help highlight the required features and thresholding. So thresholding means how much of thresholding value is there. So x-axis and y-axis, what is the threshold level? So that is an important thing. So any of the image with the appropriate filters. So filters are using to find to reduce the noise for easily finding out the segmentation or easily finding out the image or shape of the image or identifying the image originality if we are using the filters to reduce the noise. So choosing an appropriate filter that help highlighting the required features or thresholding. So segmentation is technique by which a digital image is partitioned into various image objects. Each of the pixel in a region or image object is similar concerning some property such as color, intensity, location, or texture, which can reduce the complexity of the image or easier analysis. The hidden information is also detected from the images with the help of segmentation. Segmentation algorithms work on two basic properties of an image. First one is a intensity values such as discontinuity, boundary approach. Another one is a similarity. So discontinuity and similarity. So if any of the image here, the segmentation is a technique by which a digital image partitioned into various image objects. So, how many objects are there? Object 1, and object 2. How many objects are there? That way. And each of the pixel in a region, image objects is similar concerning some property such as color, intensity, location, or texture. So each of that one. Suppose here, what is the color of this image? What is the color? So suppose here it is a black. What is the intensity value? And what is the color? and intensity, color, location or texture, which can reduce the complexity of the image for easier. Suppose I have intensity is very high, we are not identifying easily. Okay, so what we have to do? So intensity is high or color is high. What we have to do to reduce intensity? How I know? Means object is there and intensity values are there. So is it visible to eyes or not? Yes, it is visible. Then there is no need of change of intensity values. So suppose it is not a visible thing. So we have to change the intensity values or color values. So these are image objects in similar concerning some property such as color, intensity, location or texture, which can reduce the complexity of the image for easier analysis. The hidden information is also detecting from the images with the help of segmentation. Segmentation algorithms work on two basic properties of an image. First one is a discontinuity. It is also called boundary image, and similarity, region image. So boundary approach, region approach. Boundary approach and region approach. So boundaries and regions, those are the two, intensity and discontinuity. So what is the need for image segmentation? Partitioning an image into different image objects, fetching information from it and then labeling or use it to train various ML models to address business problems. For example, it would be a facial recognition system for marking attendance automatically with the help of segmentation. Another application of segmentation is in the medical field for efficient and faster diagnosis after detecting severe diseases like tumors, cancer, etc. And also for seeing the patterns in medical imagery generated by radiography, MRI, thermography, endoscopy, ultrasonography of cells and tissues. Suppose Suppose I'm taking one thing, that is a one person is there. This person I'm taking as an object. In this person, what I'm giving the algorithm is that facial recognition or face recognition of the object. So face recognition means eyes, especially eyes. So I'm capturing the eyes in the biometric. So in the algorithm, I will be prepared as a face recognition. In the face recognition, eyes are important. So the partitioning of an image into different image objects, fetching information from it and then labeling and used to train various ML models to address business problems. So in my algorithm, I will give what are the objects are there. One person, bags, some things are there, some goods are there. So every goods or every object we are giving some labeling. So when we are giving where it is going for the scanning or any of that one, image segmentation is identifying what is the label of thing. Suppose one person is an object, so it is labeling as a person. If any of the luggage, bag, square, so what is the shape and what is the object? So depends on your object and shape, it will be identifying the object and it will give the labeling of that one. Okay. For good example is a facial recognition system. For one person is there, that is an object, but I no need of object. Only I need a in that person face recognition. So in that face recognition, especially eye detection. So this facial recognition system for marking attendance automatically with the help of segmentation. It will be identifying the object. In that object, it will be identifying the face. In that face, especially it is identifying the eyes. Okay, that is an important thing of image segmentation. Another examples are using in a medical field. Suppose in the efficient faster diagnosis after detecting severe diseases, like if I want we have to find out the tumor, cancer, or seeing the patterns of medical imagery generated by radiography, MRI, thermography, endoscopy, ultrasonography of cells and tissues. So these are the important, very important role in the medical field. So image segmentation is the very helpful, and these are applications are there for image segmentation in the medical field. So image segmentation has huge applications in areas like robotics as well. And image classification is one of the popular applications of segmentation, where an algorithm is able to capture only the required components from an image. So implementing image segmentation in Python is easy to perform in order to get fast results. So if I am going for the any image object, so this segmentation has huge applications are like robotics as well. In the robo system also, we are preparing image algorithms and we are installing the robo. So it will be identifying the what are the objects, and it will be moving as a left, right, or straight, what would be. So image segmentations are very helpful in the robotics also. And the popular applications of segmentation where an algorithm is able to use to capture only the required components from an image. And implementing image segmentation in Python also easy to perform. So mostly image segmentation we are using in the MATLAB, but here Python is also very helpful to recognizing the objects easily to perform and order get faster results. So majorly segmentation methods or image segmentations are two ways, based on discontinuity, based on similarity. So what is a discontinuity? What is a similarity? So based on discontinuity, edge based detection, and based on similarity, threshold based, region based, special theory. So based on discontinuity means only some differences are there. Edge based, similarity, what are the similar things are there in the object? These are threshold, region based, special theory. And based on special theory, neural network based, clustering based, wavelet based. But as per our syllabus, what are the topics are there? Image segmentation techniques, edge based technique, region based technique, threshold technique. These are the three major things are there. And if I'm going for the edge based technique, what are the advantages? Works well when the edge is prominent. And what are the disadvantages? Could not be applied on images having many edges, not suitable for image having smooth edges. And region based techniques, advantages, better for noisy image where edges are hard to identify. Disadvantages, seed point must be specified. Different seed points may give different outputs. And the threshold techniques, what are the advantages? One of the best and easiest technique is here, is there. And disadvantages, could not be applied on images having complex intensity distribution like medical images. Cannot process the images whose histograms are nearly unimodal. So already we discussed in the previous, image segmentations are discontinuity and similarity. In the discontinuity, edge based is there, but in the similarity, threshold based, region based. Only three major things: 1, 2, and 3. Majorly three things we will discuss here, like this: edge based technique, region based technique, threshold technique. These are the three that are the discontinuity or similarity. Both are combining here. So discontinuity and similarity we are combining here. Edge based technique, region based technique, threshold based technique. But where we are using this edge based technique means it will be work when the edge is prominent. And what is the disadvantages are there? Could not be applied on images having many edges, not suitable for images having smooth edges. So many edges are there. So many edges are there. Then edge based technique is not suitable. And region based technique, better for noisy images where edges are hard to identify. Disadvantages, speed point must be specified. Different seed points may give different outputs. So benefits are there, mostly noise images where the edges are harder to identify. So if anything noisy images are there, in the noisy images also we are finding out the segmentation objects easily with the region based technique. And the threshold technique, one of the best and easiest technique is there. And what are the advantages and there, this one. And disadvantages is there, could not be applied on images having complex intensity distributions like medical images, but cannot process the images whose histograms are nearly unimodal. These are the disadvantages and advantages of edge-based technique, region-based technique, thresholding technique. So each one we will discuss now. First one is a edge-based segmentation. In this approach, the boundaries of regions are sufficiently different from each other and from the background, allowing for boundary detection. So based on local discontinuity in intensity gray level. In other words, it is a process of locating edges in an image. This is a very important step towards understanding image features, as we know that edges consist of meaningful features and have significant information. So when I going for the edge-based segmentation, so edge-based segmentation, it will be finding out the edges. But what are the disadvantages? Means if so many edges are there, it is not possible. And if it is a smoothing also not used here. Okay. So the boundaries of the regions are different from each other and from the background, allowing for boundary detection based on local discontinuities in intensity or gray level. And in other words, it is the process of locating edges in an image. This is a very important step towards understanding image features, as we know that edges consist of meaningful features and have significant information. So edge detection is an image aims to extract meaningful discontinuity in pixel gray level values. Such discontinuities can be detected from first and second derivatives as defined in Laplacian filter. The first order derivative of an image f of x comma y is defined as delta f equal to gx ga is equal to dou f by dou x by dou f by dou y, and magnitude is there, delta f equal to square root of gx square plus gy square. By using the absolute values, dou f equal to gx modulus plus modulus gy, and the second order is the dou f square equal to dou square f comma y by dou x square plus dou square f by dou y square. So edge detections are there, but how we are finding out? That means it is the extract meaning of discontinuity in pixels in gray level. So any of the pixels in the gray level values, gray level intensity values, these such as discontinuities can be detected from first and the second order. So these intensity values I have to change it. So I have to change it. How we are changing means we are going for the first and second order derivative. So however, the Laplacian filter is not used for edge detection because as a second order derivative. Why? Because it is a Laplacian. That is the reason we are going for the second order derivative. And what is the use of the Laplacian is there? It is sensitive to noise. Its magnitude produces double edges. It is unable to detect edge direction. So these are the second order Laplacian. Okay, so this Laplacian filter not used for edge detection because as a second order derivative. It is sensitive to noise. Its magnitude produces double edges. It's unable to detect edge direction. There are first order derivative estimates in which we can specify whether the edge detector is sensitive to horizontal or vertical edges or both. We study only two edge detectors, namely Sobel and Privet edge detectors. So these Sobel and Privet are very important role in the edge detection. So to finding out the edge detection, Sobel and Privet are the very important role. In the next we will discuss these Sobel and Privet edge detectors. These are the first order and second order derivatives are there to finding out the edge detections. And it is one good example for edge detection. It is the figure A and figure B. So in this figure, it is the input image, output image with edge detection. Edge detection means it will be finding out the what are the edges of there. Suppose this cap is there, what are the edges, what is the size. So depending on this one, we have to finding out like this. So what is a hair? So hair is like this. Edge detection, edges of the hair. Okay, we are finding out the edges of the hair and the face and some any of the objects of surrounding. Okay, these are the edge detection. Depending on based on edge detection, we are finding out the what is the object. We are easily finding out the object. Okay, here I am using edge detection to finding out the object. Object finding easily. So point detection is another thing for in the image segmentation. This is concerned with detecting isolated image points in a relation to its neighboring, which is an area of nearly constant gray level. And what is a simple method? The simplest method to detecting method works in two steps. First is the filter the image with a mask, and then we can take the absolute values of the filter image. On the filtering image, apply an appropriate threshold. Example, maximum pixel values. Okay. So what are the threshold levels are there? So what are the threshold levels are there? X and Y. 0 to 5 I am taking, suppose. Here 0 to 5. So x-axis and y-axis, what are the threshold levels are there? So depend on your this detecting isolated image point relation to its neighborhood, which is the nearly constant gray levels are there. So when you are finding out the gray level intensities, the simple method is the detecting method works on two steps. Filtering the image with mask. So already we know in the previously filtering, how we are doing the filtering means using mask. So how we know means mask is a 3 by 3 or 4 by 4 like this. See here it is a 3 by 3 mask I am applying. So minus 1, minus 1, minus 1, minus 1 like this. So middle point is a 8 means 2 cube. Cube is equal to 3. It is a 3 by 3. If I am taking the 4 by 4, that means it is a 16. So if it is 16, then it is a 4 by 4. Why? Because 2 power 4. So it is a 4 by 4. So middle point, edge, what is the center point of the value, matrix value. Then based on that value, we are finding out the what is the matrix size of the matrix. Okay. And on the filter image, apply an appropriate thresholding. Example, the maximum pixel level. So what is the maximum level? What is the threshold level? So we are finding out with this applying the appropriate threshold with the maximum pixel value. So with the help of thresholding, we are finding out the maximum level of the edge detection or point detection. So here some more examples of edge and point detection. So the below figure shows an example of point detection in a face image using the simple method. It is the input image. Here threshold is maximum. Here applied the mask. Here applied the mask. So the threshold level is maximum. Is it visible? No, the image is not visible. I reduced it to 220. Is it visible? No. I am reduced to 168. Is it visible? No. 118? No. 6 is somewhat. 55? Okay. Visible image. So this is a 55 thresholding value. So why? Because it is a image segmentation. So we are finding out, yes, it is a face of the image. Okay, it is a image segmentation. So it is a point detection using simple method, original face image and B to G results with different threshold levels. Maximum value reduced in the threshold value. Finally, when it is achieving the 55, we are getting the face detection easily and without noise. If anything noise is there, then we are going to the mask, applying mask to reduce the noise in the image. So based on the thresholding values also, we are finding out the image or maximum levels of the image. Another one is a line detection. So detecting a line in a certain direction requires detecting adjacent points in the image in the given direction. This can be done using filters that yield significant response at points aligned in the given direction. So when I am going to the these three, you can see here horizontal, vertical, and crossing lines. Okay, it is nothing but a line detection. Okay, every matrix I'm applying the different techniques. Okay, horizontal, vertical, and cross. Detecting a line in a certain direction requires detecting adjacent points in the image in the given direction. This can be done using filters that yield significant response at points aligned in the given direction. So when I'm using the filters means I'm applying the mask technique. And for example, it is a filter that is a mask of 3 by 3. Highlighting lines in the vertical, horizontal 45 degrees and minus 45 degrees. It is a 45 degrees and minus 45 degrees. Okay. This can be done again in two steps. Filtering in the image using an appropriate filter. Apply an appropriate thresholding. Okay. It is appropriate filter I'm using the filter. Here using the threshold. Using filter and using threshold. That is maximum value. So the next figure illustrates an example of line detection using the filters above. So figure A, B, C, D and E. So image is an input image. Then illustrate the detection of using the filters. So what are the lines are there? Here some lines are there. So we are finding out easily. So example of line detection is the original image, and B to E are the detecting the lines in vertical, horizontal, 45 degrees, minus and plus 45 degrees direction respectively. So horizontal, vertical, plus 45 degrees and minus 45 degrees. Okay. In these angles we are finding out the edge detection and line detections of the original image. And Sobel edge detector. Already we discussed in the edge detection. One of the most important thing is a Sobel edge detector, and this is a detecting process to following the mask technique is appropriated digitally with the first order derivative of gx and gy. So I am taking here 000, the like this. It is a horizontal and vertical. So any of the Sobel edge detector, we have to take the zeros as a horizontal and vertical. The remaining values are we are taking as per intensities. We are taking the positive or negative values. And what is the use means to detect the horizontal edges, the filters with F using the left mask above, and the vertical edges we filter the image F using the right mask above, and edges in both direction we do the filtering. So filtering the images F with the left mask to obtain GX, and filtering the image F with the again the mask to the GX. Okay. So when I'm going for the left mask, that is I'm taking GX. When I'm going for the right mask, I'm taking as a GY. So it is a relation between the GX and GY. So in all cases, we can take the absolute values of the filtered image, then apply an appropriate thresholding. The below figure shows the example of edge detection using a Sobel detector. Any of the Sobel detector, we have to take the values of horizontal and vertical values. And vertical values we have to take. So here it is the input image with the Sobel edge detection of the original image, and B, C, D are the edge detecting vertical, horizontal, both direction, vertical and vertical direction to finding out the edges of the input image. So another is a pivot edge detector. So Sobel detector, pivot detectors are the major role for edge detection. So So private edge detector. This detector uses the following masks to appropriate GX and GY. So horizontal and vertical values. So these are the steps by applying this detection as the same as that of the Sobel detector, as same as Sobel. But what is the difference? Means the in the example of edge detector using private detector, here we have to use original image edge detection in vertical, horizontal, and both direction respectively. But we have to use here second order value. The private detection produces noisier results than Sobel detector. So this is the because of the coefficient with the value 2 in the Sobel detector provides smoothing. So Sobel detector is for the smoothing, but here somewhat probability is somewhat noise is there. Noise will be occur, so small noise will be occur, but in the Sobel detection it is a smoothing is there. That means no noise is there. But in the figure A, original image is there. B2, C2D, vertical and horizontal are there. But maybe so the small partitions of noise will be occur like this. So maybe the chances are there of the noise. But in the Sobel, there is no noise. Why? Because we are applying the smoothing technique to find to reducing the noise. But here maybe the choices are there. So compared to private, Sobel is somewhat better to finding out the edge detections. And region-based segmentation. This approach consists of partitioning an image into regions that are similar according to a certain set of criteria. The region-based segmentation technique involves in algorithm making segments by dividing an image into various components that have similar pixel characteristics. This technique searches for small or big chunks in an input image for segmentation purposes, and it will either add more pixels to the selected chunks or further diminishing the chunk points into smaller segments and merge them with the smaller chunk points. Okay, so any of the image we are taking as a small objects, we are taking as the small objects. Okay, so it is consisting of an partitioning of an image into regions that are similar according to a certain set of criteria. So similar objects are there. What are the similar objects? We are taking as a partitioning of that object, and we are taking as our region 1 and another region 2 different objects, region 3 different objects are there. So based on the size of the image, we are taking as a partitioning as a regions. This region-based segmentation technique involves an algorithm making segments by dividing an image into various components. Every regions, every region. Suppose I'm taking region 1, region 2 like this. Every region, we are dividing an image into various components. In this region, how many components are there? Suppose one book is there. Okay, what is the size of the book? Similarity of that book. Is there any images are there? Bag is there. Same looking like a book. One bag is there. So what is the similarity means? What are the similarities means? The shape is vertical. Maybe. Okay. So how much size is there? What is the shape of that book? Similarly, bag is also same looking like, but object is different. But it is liking as a region. Okay. In the region 1, what is our shape? Yes, book is a vertical shape. So it is a not in square, suppose. So it is a taking as a one object or one region. In this region, there are so many objects are there. So this image are various components are there. So set of components I'm taking as a one region. So in that region, there are different regions are there in the region-based segmentation. Region 1, region 2, region 3, based on the size or shape of that image. And this technique searches for small or big chunks. Whatever may be, there is no rule. Small or big input images for segmentation purposes. It is either more pixels to the selected chunks or further diminishes the chunk points into smaller segments and merge them with the other smaller chunk points. Okay, these set of components are merging as a region. Set of regions are we are merging as a segments. And it is two more basic techniques based on this method. First one is a region growing and a region merging. Okay, region growing. We can see here it is a input image with a gray, that is black and white, and it is a color with color code red, green, blue. So this gray is converting to the color with the segments. Why I am calling this is a segments means we have to see here it is a cap and it is a face. So it is a background of thing. So it is a hair. So how we are finding out means with the segments I am easily finding out it is a what is the object we are easily finding out. So in the image segmentation I am gray level or black and white image is converting to the color image with the segmentation. These are the references of image segmentation. So finally we discussed segmentation is a technique by a digital image is a partition of two various image objects, and these are the two types are there: intensity values such as discontinuity and similarity. So discontinuity is one thing and similarity is another thing. So discontinuity and similarity. So what are the needs and why what is the need for image segmentation is partitioning image into different image objects, finding fetching from it, and labeling used to train various machine learning models to address business problems. So where we are using means in the medical field or in the face recognition, in the electronic boards, in the medical field, MRI, endoscopic, ultrasonic cells, tissues, etc. And image segmentation use applications are like robotics also we are using. And in the with the help of Python, we are easily preparing the Python, very easily preparing the algorithms. So majorly segmentations are two types based on discontinuity and based on similarity. So based on discontinuity and similarity, there are three types are there: edge-based technique, region-based technique, threshold technique. In the edge-based technique, what are the advantages means works well when the edge is prominent, and what are the disadvantages means could not be applied on images having many edges, but not suitable for image having smooth edges. Okay, smooth edges it is not usable. And region based technique better for noisy images where edges are harder to identify. So when is the noise is there, we are using the mask or filter to reduce the noises. That is a region based technique. And the thresholding technique means what is the highest peak value, so what is the maximum level. Maximum level of the object we are finding out with the thresholding. It is a best and easier technique. And what are the disadvantages could not be applied on images having complex intensity distributions like medical images, cannot process images whose histograms are nearly unimodal. And edge-based segmentation, we are finding out the edges of that one. And where there are two techniques are there to finding out the edges, and it is the equation for edge detection. And Sobel and Privet edge detectors are the majorly using two types of techniques to finding out the edge detection. It is one example for finding out the edges of the original image to finding out the object easily. And point detection, how many are there? Here using a mask technique to finding out to reducing the noise in the original image. And it is a good example for finding out the image with the threshold levels. And it is a line detection. It is a mask with using horizontal, vertical, minus 45 degrees, plus 45 degrees of angle to finding out the image segmentation with the line detection. And it is a good example for finding out the lines of the detection and detecting the original image. It is a Sobel edge detector. We are using, definitely we have to use two matrices. Two matrix. First matrix is for horizontal, second matrix is for vertical values. And the GX, GY are left mask values and right mask values are GY. And it is a Sobel edge detection, original values with horizontal, vertical, and horizontal and vertical values. It is a pivot edge detector. Definitely, we have to take two matrices. One is for horizontal values, another for vertical values to detecting the object of the image. But it is some noisy. We will get some noisy image. Some disturbance will be occur. But compared to pivot, no, Sobel is somewhat better because some noise may be occur in the pivot. It is one example. It is some maybe we are not identifying object. We are missing some object. Based it depends on the noises. Where Sobel detection is better. Why? Because here smoothening is applied. Smoothening is applied to detect or using filter to reduce the noise. Region-based segmentation, it is consisting of partitioning image into regions and similar according to a certain set of criteria. The region-based segmentation techniques involves algorithmics making segments dividing into a various components. So, any of the image, so these are taking as a region. These are the looking like same. It is a region 2. So, these region 1, the region 2 are the segments. So, in the region, set of components. Set of components. So, set of components are called region. Set of regions are called segments. Okay. In the set of components, how many components are there in this region means? Suppose 2. Here, same related to this one. Suppose it is a 3. So, set of components are 2 in the region 1. Set of components are 3 in the region 1. So, how many segments are there means? Total 5. How means? Region 1 plus region 2. Like this. So, it is a region based segmentation. It is one good example of a gray level to RGB, red, green, blue color with segmentations. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.